Hi friends, welcome back to Raman's tutorials for GK. This is Rangaraju M from Tumkuru. Friends, today we'll discuss about electrical energy and electrical power. As we know that energy exists in different forms such as mechanical energy, heat energy, light energy, chemical energy, electrical energy, light energy, nuclear energy, and etc. Now, electrical energy it is also a types of energy. Now, let us discuss about definition of electrical energy. Electrical energy is energy derived from electrical potential. Electrical potential energy or kinetic energy. Now, electrical energy may also defined as it refers to energy that has been to converted from electrical potential energy. Friends, in our daily life, we use many devices where electrical energy is converted into heat energy, light energy, light energy, mechanical energy, chemical energy, motion energy, etc. At that point, this electrical potential energy has been converted to another type of energy. It ceases to be it ceases to be electrical energy. It ceases to be energy, electric potential energy. Thus, all electrical energy is potential energy before it is delivered to end use. Once converted from potential energy, electrical energy can always be called another type of energy. It is in the form of heat, in the form of light, in the form of motion. Friends, let us discuss some examples regarding to the electrical energy. Now, first examples, when an electric current passed through a wire, that is the filament of an electric heater, oven or geyser. Friends, when an electric current passes through a wire, the filament gets heated, and that effect is called as heating effect of electric current, and the electric energy is converted to heat energy. So this is the effect of heating effect of electric current. Now let us discuss another one example, that is when an electric current is passed through an electric lamp. Friends, you know that electric lamp it consists of tungsten filament. When a current is passed through the tungsten filament, the filament of bulb gets heated and it glows. Friend, in this example, we clearly observed there is a two forms of energy, that is heating energy and one more is lighting energy. That means the electric energy thus changes into heat energy and sometimes light energy. Let us consider one more examples, that is microphone example. When electric energy from microphone is passed to a loudspeaker, it converts it to sound energy. That is also one of the form. Sound is also one of the form of energy. Then move to next example, that is when an electric current is passed through an electric motor, just for example fan, it begins to rotate. If it begins to rotate, then it shows that there is a production of mechanical energy, and simultaneously it gets heated. Therefore, friends, the electric energy thus changes into mechanic energy and also heat energy. From the above four examples, electric energy is converted into heat energy, light energy, mechanical energy, sometimes it converts to chemical energy. For in electrolysis, we observed when a current is passed through the solution, for example sodium salt NaCl, sodium chloride solution, it dissolves into two parts, that is Na plus Cl minus. So that is chemical energy. Electrical energy is converted to chemical energy. My dear friends, now we will discuss about some expressions for the measurement of electrical energy. By the definition of potential difference, the work done in moving a charge across the ends of conductor is given by W is equal to Q into V, call it as equation number 1. But Q is charge and it is defined as the product of current and time. Current means flowing of electrons in a conductor, that is I current, and time how much electrons is flowing in a per unit square length of conductor. And therefore, by combining equation 1 and equation 2, we will this W is equal to, that is energy is equal to VIT, call it as equation number 3. Already you know that Ohm's law is nothing but V is equal to I into R, that is current and resistance of a conductor. Here the resistance means the substances or the conductor, it resists the flow of current, that is called a resistance. From equation 3, W is equal to I square RT, W is equal to I square RT, call it as equation number 4. Friends, here in equation number 1, W is equal to Q into V, it is also expressed in terms of joule, and similarly in equation number 2, Q is equal to I into T, it is also expressed in terms of joule. Similarly in equation number 3, equation number 4, and then again apply Ohm's law, I is equal to V by R. Therefore from equation number 4, substitute the again equation 4 here, then it implies W is equal to V by R whole square into RT. Here in this equation this implies V square by R square, therefore R get cancelled and remaining V square by V square T by R, call it as equation number 5. Friend, from the above 5 equations, we can easily decide in all the equations, W is equal to Q into V, that is also a joule, and Q is equal to I into T, that is also joule, W is equal to VIT is also joule. Therefore the unit is joule, that is joule. Therefore, the SI unit of electric energy is joule. By knowing these formulas, that is W is equal to QV, Q is charge, V is voltage or potential difference, and also W is equal to V into I, that is product VIT, product of voltage, current and time. It is also expressed in terms of joules, and also is equal to I square RT. I square is I is current flowing through the conductor or the resistance of conductor, T is the time. Then joule, it is also in joule, and V square T by R, it is also joule. By knowing these 3 to 4 formulas, we can easily build a relation between electrical energy, charge, voltage, current and resistance. Therefore, it is easy to remember the formula, that is W is equal to VIT, and then at the same time remember Joule's formula, V is equal to I in Ohm's formula, V is equal to I into R. Now friends, let us discuss about electrical power. What is the meaning of power? Power means capacity to do work. Yes, that is the rate of doing work. Power is the rate of doing work. Power is the rate of doing work in 1 second. Rate of doing work, or it is a work done in 1 second. In 1 second. Once again, power is defined as the rate of doing work, or it is the work done in 1 second. Friends, power may also defined as in different ways, that is power is as the rate at which electric energy is supplied, rate at which the electrical energy is supplied by the source. One more definition is there, that is power is the product of V I into V. Once again, power is the product of I, power is the product of I into V, that is product of I into V. So this is the power. Now formula, that is power is equal to energy supplied by time, that is W by T. W by T. So this is the energy supplied by time. We have W is equal to VIT. VIT, substitute here, then TT get cancelled, V into I. So this is the formula, first formula for power. Power is equal to VI. By Ohm's law, V is equal to I into R. Substitute the here in place of V, I into R, then it implies, equation 1 implies I square R. Once again, by apply Ohm's law, I is equal to V by R. Here in this condition and this condition, they are same Ohm's law but in different forms. Here V is equal to I into R, here I is equal to V by R. Just doing cross multiplication. No different formula here. Then also by Ohm's law, I is equal to V by R, and substitute here, equation 2 implies V power is equal to V square by R. Power is equal to V square by R. Yes friends, so these are the three formulas to find the how much power is consumed in an electrical appliances. The first formula is P is equal to V into I and then W by T, and then I square R, and then V square R. Now let us discuss about the units of power. The SI unit of electrical power is watt or joule. The SI unit of electrical power is watt or joule. Friends, how to define watt? It is very easy. We have power is equal to V into I or I into V. If voltage across the conductor between 2 points is 1 volt and current is 1 ampere, then power is equal to 1 watt. Thus, if potential difference of 1 volt, look here, potential difference of 1 volt causes a current of 1 ampere to flow through a wire. 1 ampere of current is flowing through a wire. Across the wire there is a 1 volt potential difference. Then it is said to be the electrical power consumed is 1 watt. That is, apply the here P is equal to 1 by 1, that is equal to 1 watt. P is equal to 1 watt. Now, commercial units of electrical energy. Friends, commercial units of electrical energy, it is also called as Watt unit. Do you know the meaning of Watt unit? Let's know that what is the Watt unit. Watt means Board of Trades unit, BOT, BOT, Board of Trade units. That is, it is used for trading purposes or commercial purposes. Friends, commercial units of electric energy, it consists two units. First one is 1 watt hour and the next one is 1 kilowatt hour. Here 1 watt hour and 1 kilowatt hour. Now let us discuss one by one. What is 1 watt hour? What is 1 kilowatt hour? What is the differences between these two, that is 1 watt hour and 1 kilowatt hour? Now 1 watt hour. 1 watt hour is the electrical energy spent by an electrical appliances of power 1 watt when it is used for 1 hour. That is, 1 watt of power is used by the electrical appliances in 1 hour. It is nothing but 1 watt hour. 1 watt hour is nothing but 1 watt into hour. 1 watt into hour can be converted into 60 into 60, that is 3600 joule. 1 watt hour is 3600 joule. Now friends, let us discuss about 1 kilowatt hour. It is similar to the 1 watt hour, but here only one difference is kilo. Kilo is nothing but 1000 watt or 10 to the power of 3 watt. Here 1 kilowatt hour is the electrical energy spent by an electrical appliances of power 1 kW, that means kilowatt, when it is used for 1 hour. That means if an electrical appliances or home appliances used or consumed a power of 1 kilowatt in 1 hour, then it is said to be 1 kilowatt hour. 1 kW, it is called as 1 kWh, 1 kilowatt hour. Now 1 kilowatt hour is nothing but 1 kilowatt into hour. Kilo is nothing but 1000 and hour is nothing but 60 into 60. Therefore, on simplifying, we get the answer, that is 36 followed by 50. In 36 followed by 50 can be written in the scientific manner, that is 1 kilowatt hour is equal to 3.6 into 10 raised to the power of 6 joule. Now 1 watt hour is 3006 joule and 1 kilowatt hour is 3.6 into 10 to the power of 6 joule. Friends, let us compare these values. Here only 3600 joule only, but here it is 3.6 into 10 to the power of 6 joule, that is 36 lakh joule. Therefore 1 kilowatt hour is 3.6 into 10 raised to the power of 6 joule, that is 1 kilowatt hour is biggest commercial units compared to the 1 watt hour. Yes friends, from beginning to till we'll discuss about some concepts of electrical energy, user applications of electrical energy, conversion of electrical energy into various forms, and also the powers, definition of powers, and also the commercial units or boards units of electrical energy. Now let us discuss some problems on electrical energy. Friends, in any competitive examination, the questions arised on the problems or questions arise in the essay.